to 6.8, reteaching. So if we look here, we need to do 3 things for each one of these problems. We have to first state the transformation. We have to then graph the function, and we then have to state the domain and range here. Now when I am doing this, one thing I have to know what the parent function looks like. If I don't know what the parent function looks like, it's pretty hard to do. So I'm going to draw the parent function over here. Parent function, this is going to be my xy axis. Parent function, my vertex starts at the origin, 0, 0. Now one thing when you're doing this, my parent function is just the square root of x. So sometimes it will be easier if you pick one point to try to solve. So if I try to put, let's say, 4 in for x, if I put 4 into my parent function right here, I get the square root of 4, which is equal to a positive 2. So then I could plot this point, 1, 2, 3, 4, 1, 2, put a point right there. This is really bad because of my spacing, but that would be where my parent function looks like. And when I say this transformation for all these problems, it's the same type of thing that we have been doing since last semester. So first, when I'm looking at this problem, I'm doing A first. State the transformation. So I have to think, this -5, is it on the inside of the equation or outside? How do I know if it's on the inside or outside? It's on the inside if it's doing the arithmetic problem. It's on the outside if it's just adding or subtracting to the equation. Well, looking at this problem, the -5 is inside the radicals. That means it's doing it to the problem. It's being square rooted. So inside is left and right. Inside is always opposite. So in this case, if it's a -5, that means it's actually going to be moving right 5. So that's all my transformation is here because that's the only number I have. So B is going to actually be graphing it. So if I move right 5, that means I start my origin at 0, 0, but then I move right 5. Here is my point right there. Now when I'm going to be solving this, I'm going to just put a point in anywhere on the right-hand side. Front to make that point anywhere on the right-hand side. I'm going to try 9. You could use a decimal. Actually, maybe I'll do a decimal. Let's say if I try a point 7. I'm going to plug 7 to my equation. So 7 minus 5, and then take the square root of that. I get 1.4. The reason why I'm doing this is just so it can help me draw the picture. So here's 7, here is 1.4 about right here. So I have 2 points now. Here's my graph. It should have a curve. See how it has a curve right here? It has a curve and it has an arrow. So that's my graph. Now, when you are doing this, it's always nice to write this origin right here. So my domain here would be a 5, 0. My vertex, not domain, vertex. Now I'm going to do my step C. My domain. Remember, domain is how far left and right you go. So I'm going to for sure have x, because that's x value is left and right, and then my x value here is 5. So now I have to think, when I'm looking at my x value, right here, here's my x value, and then I have to think, does it move to the right, or does it move to the left? So in this case, it's moving to the right. So that means x is getting larger. So this would be x is larger or equal to 5. Now I'm doing my range. And it's the same type of thing, except now I'm dealing with my y. And my y value here is 0. So if I look again at this, let's see if I can. Oh, can't turn it. Well, then I look up and down. So is my y getting larger? Is my graph above this point? Or is my graph below this point? That's what you have to be thinking. It's above this point, so y is getting larger. So y is greater than or equal to. So those are my 3 answers for this one. Kind of took a long time. That's okay. Next one, number 2. First thing, describe the transformation. When I look at this, the plus 2 is on the outside of the equation. I'm just adding here. That means I'm going to go up 2. So here's my vertex, 0, 2. And you want to plug in a point for x someplace on the right-hand side. I'm going to plug in 4. So if I plug 4 in, the reason why I'm picking 4 is because I know I'm going to have to take the square root of it. And it's just easier to do in my head. So the square root of 4 is 2. 2 plus 2 is equal to 4. So this is a point on my graph. So I'm going to go 4 and then 4. So this is my second point. That just helps me actually graph the function. And again, it should be some sort of a curve here with an arrow. And now I'm doing my domain and range. So I have my domain, I have my range. Domain is always your x values. Domain is always your x. Range is always your y. This point, your vertex point, is 0, 2. So 0 is your x, y is your 2. Now you have to look at the graph again. When I'm looking at this graph, the range, or the domain, moving left and right. Is my graph moving left? Is my graph moving right? My graph is moving right, so that means x is getting larger when I move to the right, or equal to. And I look at my range. Here's my point. Is the graph moving up? Is the graph moving down? Well, the graph is moving above that point. So that, again, means y is greater than or equal to. Next problem. Here I have two different things going on. So I'm stating my transformation. This negative, if it's multiplied by a negative, that means it's going to flip. And then I look at my 4. It's on the inside of my equation. Inside moves left and right. Inside is always opposite, so this is actually going to move left 4. So when I write my vertex, it's only left 4. That's the only thing I'm doing here. Now I'm actually going to solve for a point to help me know where to draw it. I'm going to plug in 0 into my equation. Again, it does not matter really what point you plug in. Just make sure that when you're doing it, you're plugging it in correctly into your equation. So if I plug 0 into this equation right here, I'll get negative 2 out. So that's the next point I'm going to plot, is 0, negative 2, right there. And I'm going to draw my graph. Again, some kind of curve when you're drawing. This point was 0. Nope, it wasn't 0. This point was negative 4, 0. Because now I have to do my domain and my range. My x is my negative 4. My y is my 0. X value was negative 4. Y value was 0. So look, you always start at your vertex. X, did I move left or did I move right? If I look from here, from my vertex, I'm moving to the right. So that means x is greater than or equal to negative 4. For my range, up and down. So starting at my vertex, it looks like my graph moves down. Y is getting smaller and smaller. That means y is less than or equal to 0. That's my domain and range. And last, but not least, I see two things going on here, 2. So my transformation, 1 I see multiplied by a 2, so this is going to be a stretch because it's larger than 1 of 2. And also the 3 is on the out-hand side, the back side, so it's going to go down a 3. So that's going to help me know my vertex. If I move down 3, here's where my vertex is. And I'm going to plug in, let's do 3. I'm going to plug 3 into my equation. So this is what I am solving for to figure out what my y value is. I get that this is equal to 0.46. I'm going to just say 0.5. So I'm going to graph that positive 3.5. So about right there. So this is what my graph looks like. Again, kind of follow it up and it should be some sort of a curve. Now my domain and range. My x is with 0. X is with 0. My y is with negative 3. And if I look here, my graph is moving to the right-hand side. It's moving to the right. X is getting larger. My graph is moving up. If it's moving up, that means y is also getting larger. So they're both greater than, equal to, greater than, equal to. That's the review for reteaching of 6.8. Thank you. Thank you very much, you beautiful audience. Have a great day.